Hey there, this is the second part of the trig ratio review. Hopefully you've already done part one, and just like before, how about you turn off the video, do the questions, and then come back or check the answer key and see how you did. Okay, let's get started. Oh, let's see, I don't know. I'm gonna do what I always do first. I'm gonna label, because the labeling tells me what I'm gonna do afterwards. So there's my hypotenuse across from my right angle. We go around the corner, and that makes this the adjacent. And this one over here, the opposite. And we are looking for the angle. So what have I got though? In this case, I have opposite and adjacent. And since I have if you're clever and you watch the other video, you already know we did the sine and then we did the cos. So, yep, it has opposite and adjacent in it. We're going to look at tangent. So tan theta is opposite over adjacent. Tan u, 16 over 15. I could have left theta, I usually do, but the diagram's all pretty and it's got the angle labeled as u, so let's use u. Tan u is equal to 16 divided by 15, 1.06. I'm just going to do repeating like that. Now, to get from tan u, so this is the ratio of the two sides involved for this angle. To get the actual angle, so angle u, I need to go tan to the -1 or second tan, whichever one you want to call it. So it's the inverse tangent. So second tangent. Now, my calculator is cool. I just see equal sign and it puts my answer in from last time. And we're going to say 47 degrees. Now, if I go second tan and I go 1.06, you know what, it would still round to the same thing. That one was closer. This is the exact value if I just do it, but when you round it to one decimal place, it's still gonna work. All right, cool, whoopsies. By the way, if you wanted to find the hypotenuse, you could use cos or cosine, or you could use Pythagorean's theorem. But Pythagorean's theorem is a different section, so we're not going to touch that here. All right, solve all the triangles by dividing all the angles on all sides. All right, well, what do we know? Let's just solve stuff. Hold on, something's come up. Sorry about that. Let's get back to this triangle here. Well, you know what? I'm just going to ignore this stuff right now. I am going to worry about labeling. So we go across. There's my hypotenuse around my corner, right? Because that's where the theta is. So I'll use that to start, which makes this adjacent. And this side opposite. So, I think we can start here. Let's find angle A first. And we have hypotenuse and adjacent, so that's going to be cosine. Cosine theta, adjacent over hypotenuse. Cosine theta, adjacent side is 6 over 9. Cos theta, 6 divided by 9. 0.6 repeating. And then you do All right, second cos, last time. I know I wrote cos to the minus 1, I mean the same thing. So second function and cos can equals, and so theta, notice how cos disappears now when you do that inverse. So angle theta is equal to 48 degrees. Now, if you haven't watched a lot of my videos, this will surprise you. I'm a paranoid mathematician, so I could just say, well, all the angles in a triangle are 180, and I've used up 90, and I've used up 48, and I can scrap to get that one. I don't think I want to, but maybe I have to. Never mind, I have to do that simply because I don't have the opposite side. Hold on, gotta think. Nope. So this is, basically this is angle A. Angle B, I have a plan, took me a second there. If I think about angle B, and I'm gonna put my theta. Okay, so ignore this one now. So if I go hypotenuse and I go around the corner this way, this becomes my adjacent, and this becomes my opposite. You know that, right? When you flip from one angle to the other, your adjacent and opposite flip too. So then using my green pen, I now have opposite and hypotenuse. So I can use my calculator. So opposite and hypotenuse is sine. Sine theta the opposite side is 6/9. I know it's exactly the same numbers, but because we're going to use sine, it's going to be a little bit different. So sine theta 0.6 repeating. And then we go sine and enter. Whoa, okay. And then every once in a while you do something really stupid and you can see there's no way that that's my answer. What did I do wrong? Yeah, I should have gone second in sine, not sine. Let's try that again. 6 divided by 9. And then go second sine. There we go. Excuse me, so theta is equal to 42 degrees. All right, we round that 41.8 is 42 degrees. Now we can do our check. We have angle C is 90 degrees plus angle A is 48 degrees plus angle B is 42 degrees. 90 plus 48 plus 42 is 180 degrees. See, when I do it this way, yes, of course, it's a little more work, but I mean, I'm going for practice here. But I can do a check and I know I'm right. If, on the other hand, when I got here, I said, well, there's 180 degrees in a triangle, minus my square corner, minus the 48 I got, 180 minus 90 minus 48. Yes, I got the same answer. But if I screwed this one up, then this one is messed up. This way, I know everything is okay. We are, though, still missing one of the sides. So how are we going to solve for that? Since this is the trig section, nope, I was going to say this is the trig section, so I'm going to use trig to solve for it. But then I'm using my answers. This is a paranoid mathematician showing up again. I don't want to use my answers to keep calculating. So I am going to bring up Pythagorean's theorem. If you have two sides of a triangle, which I do, you can always find the third side using Pythagorean's theorem. Now, many of you if you haven't watched my Pythagoreans videos, are used to that. I don't use it. I use my version. Because I always find students need to pay real close attention where the hypotenuse goes, and sometimes they forget. But when I write it like this, you don't really have a lot of choice. This way, you might just plug the numbers in wherever and hope for the best. If you're used to using this, go ahead and use it. We can take a look, and if your answers match mine, perfect. All right, so hypotenuse, which is 9 squared. Now, it says side and side, so it doesn't matter which is adjacent or opposite. So it's going to be 6 squared plus side squared. So 81 is equal to 36 plus side squared. Okay, so this is a multiple step equation, so I'm going to subtract 36. 81 minus 36. Woohoo, it's 45. Is equal to side squared. Now, there's no way that this side of the triangle is going to be 45, but side squared is. So we need to do one last thing. Square root here, square root there. And 45. 6.7. And look here, that should probably just be rounded to 7 is equal to the side. Now, let's fill in this little chart. So angle A, we said, was 48 degrees. I'm going to put it in there. It's kind of messy. Angle B, we said, was 42 degrees. And angle C was a gimme because it's 90. If you remember from the Pythagoreans video, or you know from before, when you have the lowercase letters, that refers to the length of the side opposite. So lowercase a is the side that's opposite over here. So that's going to be 7. So this is little a, this is little b, and this is little c. Little b is 6, lowercase, and lowercase c is 9. And we don't have the units, so it's fine. The only other thing I could check, well, 2 things. One, this is a side. It better be smaller than my hypotenuse. That one you should do every time. Always hypotenuse is the longest side. One other thing we can do is from our angles, angle B is the smaller, right? This one's smaller, which means the side opposite should be the smallest side. And that worked out. Oh, I like how that looks there. All right, awesome. That is the end of the trig review.